You ever see one of those giant ships out on the water and just wonder, what's really going on inside? Well, today, we're going to take you on a pretty unique architectural tour. We're going to look at its hidden skeleton and explore the incredible engineering from the very front to the very back. And our guide for all this, it's the amazing work of Dr. Samit Tawfik. So let's jump right in.
Just look at this thing. The sheer scale of it is mind-blowing. The bow of a ship is an absolute beast. This is the part that takes the full force of the ocean head-on. And when you get a chance to see it out of the water like this, you really start to appreciate the complex curves and just the immense strength it takes to do that job, day after day.
So here's our plan for today. First, we'll look at the sleek outer shape of the bow. Then, we're going to peel back that steel skin and see the powerful skeleton hiding inside. We'll also trace the surprisingly complex journey of the anchor chain, and then we'll head all the way to the stern to see how these ships handle the forces of steering.
All right, first stop, the shape of the bow. You know, it's not just about looking powerful or impressive. Every single curve is meticulously designed for one big reason: to slice through the water with as little effort as possible.
So what is the bow, really? Well, in the simplest terms, it's the tip of the spear. Its whole job is to cleave the water, creating a path for that enormous hull right behind it, letting it slip through with minimal resistance.
Now, you've probably seen this strange-looking nose on the front of a lot of modern ships, usually right below the waterline. That is called a bulbous bow, and it's actually one of the most important innovations in modern ship design.
So what's the deal with this giant bulb? Well, it's a super clever bit of physics. The bulb creates its own little wave out in front of the ship, and that wave interferes with and kind of cancels out the main wave the bow is making. What's the result? Less drag. And less drag means you get more speed, way better fuel efficiency, and even a smoother, more stable ride.
Okay, so we've seen the outside. Now for the really cool part. Let's get out our imaginary X-ray goggles and explore that hidden skeleton inside the bow. This is the framework that has to stand up to the relentless, crushing pressure of the sea.
And here it is, that hidden skeleton. I mean, it looks like a crazy web of steel because, well, it is. But every single one of those pieces has a critical job to do in keeping the ship together. Let's start breaking it down.
So as a ship plows through waves, the water pressure is constantly pushing on the hull, right? It actually flexes the steel plates in and out, kind of like the ship is breathing. And that motion, it's literally called panting. So to fight this, engineers build this grid of panting beams and panting stringers. You can totally think of it as the bow's rib cage, holding its shape against all that force.
Right at the very tip, at the pointy end of the ship, the structure gets even beefier. That leading edge is a solid round bar called the stem bar. Think of it like the ship's chin, taking the first impact from every wave. Then, connecting the two sides of the hull right at this point are these crucial pieces called breast hooks.
So what on earth is a breast hook? Well, it's a thick, triangular slab of steel that horizontally ties the port and starboard, the left and right, sides of the ship together right at the front. The best way to think about it is like a gigantic staple, just preventing the bow from being pried open by the force of the water. If you go deeper into the structure, you find these things called deep floors, which provide massive vertical strength. And then, tucked behind all of this is maybe the most important safety feature of all, the collision bulkhead. This is a thick, watertight wall that acts like a firewall. It's designed to contain any flooding and, hopefully, save the ship if there's a head-on collision.
Okay, but the bow isn't just about pure structure, it's also home to some seriously heavy-duty equipment. So let's trace the hidden path of that massive anchor chain from the bottom of the sea all the way into the guts of the ship.
This journey has 4 key steps. First, the chain comes up out of the water and enters the hull through something called the hawse pipe. On deck, it's guided onto the windlass. That's the powerful winch that does all the pulling. From the windlass, it drops straight down through the spurling pipe, and finally it rests deep inside the ship in the chain locker.
This diagram really shows you the whole system. You can see the hawse pipe angling up to the deck, that powerful windlass that does all the heavy lifting, and then the chain just dropping straight down through the spurling pipe into its storage deep in the hull.
Now, it's super easy to get these two mixed up, so let's make it crystal clear. The hawse pipe, that's the angle tube. It brings the chain in from the water and up to the deck. The spurling pipe, that's the vertical tube. It takes the chain from the deck and drops it down into its storage locker. One brings it in, the other puts it away.
Okay, tour's moving on. Let's leave the bow and travel all the way to the back of the ship. It's time to explore the aft end, which has a completely different set of problems to solve. This is where you have to handle the immense forces of propulsion and steering.
What you're looking at here is some of the most solid, heavy-duty construction on the entire vessel. This area has to deal with the incredible twisting force, the torque, from the giant propellers, not to mention the massive side-to-side pressure on the rudder. You can see the thick plating, the deep solid floors, and that huge central casting that basically forms the ship's backbone back here. The star of the show back here is the stern frame. It's a massive steel casting that's basically the stern's spine. It holds the rudder trunk, which is a reinforced cylinder for the rudder's turning mechanism. You've also got solid floors for side-to-side strength, and the whole thing is topped by the poop deck, which, yes, is its real name. It's just the deck that forms the roof of the cabin at the back.
And just like the front of the ship has that collision bulkhead, the very back is also sealed off by the aft peak bulkhead. This creates a watertight compartment called the aft peak tank. And what's that for? Well, it's often filled with water for ballast. By adjusting how much water is in this tank, the crew can trim the ship, fine-tuning how it sits in the water for the best stability and efficiency.
And that brings our tour of the ship's forward and aft construction to a close. We have to give a huge thank you again to Dr. Sami Tawfik because his detailed work is what made this whole explainer possible.
So we've looked at the bones of the ship, right? The structures that give it its shape and all its strength. But that just makes you wonder, what about the nervous system or the circulatory system? What other hidden networks of pipes, wires, and machines are working deep inside to keep these incredible giants of the sea alive and running?